Now we've been talking about index of refraction. What happens when you have light traveling through multiple layers of different things that have different index of refractions? What I'm talking about, say we have air. And light is traveling through the air, and then it hits, let's say, your window pane. So it hits your glass. And we're going to, for our part, we're going to call this the flint glass. Okay? And then it goes through another layer, and I'm going to call this water. And then finally back out to the air. Okay? And this is all air. And this is all air. So what goes on? We know the index of refraction for air is 1. Flint glass, the index of refraction is 1.6. For water, the index of refraction is 1.33. And then back out to air is 1. Well, we know light comes in, we're going to say it comes in at 30 degrees. And it hits our boundary at 30 degrees. Well, we know in of the flint glass is more than 1, so it's going to bend more. And then we have it hitting the boundary between the glass and the water. Water is less, so that means it will bend out more. So each time it hits a boundary, the angle changes. So what we are going to look at is the first boundary, this air and flint glass, and see what happens there. So we know we have air. And we know the index of refraction for air is 1. And we know it's coming in and hitting this at 30 degrees. So theta 1 is 30 degrees. And we know it is going into flint glass. And I am going to say my flint glass has an index of refraction, and since it is our second material, it's an N2. Our flint glass is 1.6, and we don't know what that angle is, but we need to find it, theta 2. So what do we know? We know N1 sine theta 1 equals N2 sine theta 2. Put in our numbers. We know 1 times the sine of 30 has to equal 1.6 times the sine of theta 2. Well, the sine of 30 is 0.5, so this is 1 times 0.5 has to equal 1.6 times the sine of theta 2. 1 times 0.5 is 0.5, so 0.5 is equal to 1.6 sine of theta 2. So we want sine theta 2 by itself, so we divide both sides by 1.6, so that gives us sine of theta 2 is equal to 0.5 divided by 1.6, which is 0.313. Now we need theta by itself. So this is an inverse. So theta 2 is equal to the inverse sine of 0.313. And need to make sure your calculator's in degrees, and sine inverse is the second sine button. And that gives us an angle of 18.2, but I'm just going to shorten it down to 18 degrees. So what does that look like? So we know now at our interface of the air and flint glass, the angle of incidence is 30 on the air side, and it's refracted 18 degrees. Now that light beam continues traveling on, and it hits water. We know the index of refraction for water is 1.33. What else do we know? Well, we know from geometry this angle also has to be 18 degrees. And we know that from our index of refraction, this number is bigger than this number, so that means this angle is going to spread out and should be, if we do our math right, should be bigger. So now we are going to look at this interface. So now our flint glass becomes our N1 and our water becomes our N2. Okay, so what do we know? Figuring it out, this is what we know. We know flint glass N1 is 1.6. It is impacting the surface between the water and the glass at 18 degrees. So we need to find that theta 2. Back to our equation. N1 sine theta 1 equals N2 sine theta 2. So N1 is 1.6 sine of 18 has to equal 1.33 sine of theta 2. Okay, 1.6 times the sine of 18. 18 is 0.309 equals 1.33 sine of theta 2. 1.6 times 0.309 is 0.494, and that equals 1.33 sine theta 2. Divide both sides by 1.33. That gives us the sine of theta 2 is equal to 0.494 divided by 1.33, which equals 0.37. So we know the sine of theta 2 equals 0.37, so that means theta 2 is equal to the inverse sine of 0.37, which is 21.7 degrees, and I am going to call it 22 degrees. So what does that mean for our picture? So now we're back to it going out of the water into air. We know the angle of incidence is 22 degrees. We know N is 1.33 for water and 1 for air. This is a larger number, so that means this angle here should be larger than 22 degrees. This is the angle we're hunting, theta 2. So let's look at this section. We know N1 is 1.33. We know theta 1 is 22 degrees. We know N2 is 1, and we don't know theta 2, but we need to find it. So we know N1 sine theta 1 has to equal N2 sine theta 2. So we have 1.33 times the sine of 22 has to equal 1 times the sine of theta 2. 1.33 times the sine of 22. The sine of 22 is 0.37 equals 1 times the sine of theta 2 is just sine of theta 2. So 1.33 times 0.37 is 0.498, which is equal to the sine of theta 2. I'm going to go ahead and round. So this is the same thing as 0.50 equals the sine of theta 2. You do the inverse sine. So sine of theta 2 is equal to 0.5. So that means theta 2 is equal to the inverse sine of 0.5, which is 30 degrees. So what does this look like? Back to our illustration. So light enters through air at 30 degrees. It travels through the flint glass and is refracted to 18 degrees. It travels, and that 18 degrees is then incident upon water, which refracts it to 22 degrees. Then that ray is then incident at 22 degrees back into air, which exits the water at 30 degrees. You notice it's here is 30 degrees and here is 30 degrees. You should get that if nothing else is going on in the material.